now I will give you some example from chapter 3 and the common mistake they usually students do and how you can avoid them. And the chapter 3 is related to chemical bonding. Okay, let's see this question. Which type of bonding is present in magnesium chloride? Most of the students get confused about the bonding that is present in different compounds. Either it's covalent bond, it's ionic bond, or metallic bond. So to solve this trick, you have to first look at the elements that are present in that compound. If you see, we have only two types of the elements present. One is magnesium and the other one is chlorine. And the periodic table will be given to you in the exam at the end of the paper. So you can see at there that in the periodic table, magnesium belongs to group 2. So it means it is a metal, whereas chlorine belongs to group 7 and it is a non-metal. Whenever you have one metal or one non-metal or maybe two non-metals in this case, so it means the combination of metal and non-metal will always produce an ionic compound. There is no doubt in it. Only ionic compounds can be made through the metals and non-metal reaction. So you have to choose the best option that can decide. So if you see here, the option B has ionic bond. It is written already here. So the bonding that is present is ionic bond, and no other option is showing the word ionic bond. So it means you don't have to read it completely. Just choose the option B. That is the right option. Okay, so option B is correct. Let's see another question. The table shows the electronic structure of 4 atoms. If you can see over here, the electronic structure is already given. Which 2 atoms combine to form a covalent compound? So again, this question is asking about the bonding in the covalent compound. So remember that covalent compounds are always made by non-metal and non-metal. Okay, even if the students know that they are made by non-metal and non-metal, then how they will decide that which one is a non-metal? Remember, you have to remember the group number. Group 1 to 3 are always metals, whereas group 4 to 7 are the non-metals. And group number always tells you the last shell electrons. So the last shell electrons, we can see here how many electrons are present in the last shell? Only one. It means W belongs to group 1. So it is a metal. It's not a non-metal. So it is not involved in covalent bond. X belongs to group 4. It means it's a non-metal, right? Because 4 to 7 are the non-metals. It means this is involved in the covalent bonding. Let's see about Y. Y belongs to group 7. If you see the last shell electrons, it's 7. So it means the group number is 7. So it is also a non-metal. If you see this one, Z belongs to group 8. It means it belongs to group 8. It is a noble gas, and noble gases don't react with any other element. Their electronic configuration is complete. They don't need any electrons. So it means noble gas will not react with anyone. So we are just left with X and Y. So when X and Y will react with each other, they will give you a covalent compound. So this is how you can solve the question. So you have to remember that group numbers are actually the one that are deciding the number of electrons in the last shell. And period number decide the number of the shells. For example, it has 3 shells, so it means W belongs to period number 3. These all of them belongs to actually period 3 because they all have 3 shells. Okay, so now which option is right? Option C is the right option because X and Y both are non-metals. Let's see this question. Question 12. Ammonia is a covalent molecule. Which diagram shows the outer shell electron arrangement in a molecule of ammonia? This question is a must question in an exam. You will see this question, but most of the students who do the mistakes is that they know the how the ammonia will form the bonding. They know this one, but they forget about the electron pairs that are not involved in bonding. For example, most of the student will try to choose an option A, which is wrong. Why? They think that, okay, ammonia is making 3 bonds with H, right? So they think, okay, 1 bond, 2 bond, and 3 bond. And they think that, okay, option A is right, which is not right. Why? Because if you remember, if you see in the periodic table, nitrogen belongs to group 5. So it means it should have 5 electrons in the last shell. But if you see here, they are just showing 3 electrons. Where are the remaining 2 electrons? You have to show them in your electronic configuration, because whenever you are drawing the structure, you are drawing the structure of the last shell electrons, all the electron present in the last shell. So option C is the only right option because you can see these 2 electrons also here, but you cannot find these electrons here. and also not here. So that's why option C is the only right option. Please don't forget about the lone pair or the pair of the electrons that are not involved in the bonding, but they are present in the last shell. Okay, you have to remember them. Just look at your periodic table if you are confused, and you can know that how many electrons are present in the last shell. Okay, so option C is the right option. Question 13. Which diagram shows the covalent bonding in a molecule of carbon dioxide? Again, how you will know that it's a covalent bonding? It's already given in the question. But sometimes if they don't give you in the question, you just have to look for carbon. Carbon is a non-metal and oxygen is also a non-metal. So it means it's a covalent compound. Okay, whenever you are looking at the bonding, you have to remember their last shell electrons. How many electrons are present there and how many they need them. So if it means if carbon belongs to group 4, how many electrons it needs? It needs 4 electrons. So its oxidation number is 4. Whereas oxygen belongs to group 6. So it has 6 electrons in the last shell. So how many electron it needs? It only needs 2 electron to become 8. So that's why the oxidation state of oxygen is 2, whereas the oxidation state of carbon is 4. So oxidation state is the state which will decide that how many electrons an atom can lose or gain or can share. So carbon should share 4 electrons now because its oxidation number is 4. You can easily see here, right? Whereas oxygen oxidation number is 2 because it belongs to group 6, so its oxidation number is 2. It just needs 2 electrons to complete its outermost shell. So oxygen must make 2 bonds. So if you see, this oxygen is also making 2 bonds and this one is also making 2 bonds. So that's why option C is the right option. Okay, I hope this point is clear to you. So oxidation state will be the one that will decide the bonding. How many number of bonds an element can form or an atom can form, it depends on its oxidation number. Let's see another important question that is related to intermolecular force or the attractive force, you can say, between molecules. One thing you must know that intermolecular force is only present in the covalent compounds. It is not present in the ionic compound. It is not present in the metallic elements. Okay, only covalent compounds have intermolecular forces, and these intermolecular forces are actually the weak forces, and these forces are usually present between the molecules. Okay, between molecules. For example, if you have a water molecule, right, this is H2O, so which bond is present? Hydrogen is a non-metal, oxygen is also a non-metal, so this is a covalent bond present in it. If I write the structure of the H2O, you can see. So what is this bond? This is covalent bond. Okay, so in one bottle of water, you don't have only one molecule of water, right? You have so many molecules of water. So these molecules are connected with each other through weak intermolecular forces. We can also call them intermolecular forces. Okay, so that's why the boiling point of water is low. Why? Because when you boil it, this force will break. So in exam, if they ask you that why, which statement describe the attractive forces between the intermolecular forces or whatever, you have to choose the word weak forces. Okay, intermolecular forces are always weak. So option C or D can be right because they are weak forces. And where are they present? They are only present in the covalent compounds. No other element or no other ionic compound they are present. So which option is right? They are weak forces formed between covalently bonded molecules. So it means option C is the right option. They are weak forces that hold ions together. No, that's wrong. Okay, they are not present in the ionic compound. So option C is the right option. Again, similar question that is related to the intermolecular force. Student does a lot of mistake in this one. Because if you see, why do most covalent compounds have low melting point? They think that, okay, covalent bond is a weak bond. That's why they have the low melting point. So what they usually do, they choose the option A because their atoms are loosely held together by weak covalent bond. Again, this is wrong. Covalent bonds are very strong. They are not weak. Okay. So what is the thing that is responsible for the low melting end point? It is actually the weak intermolecular forces, or we can also call them weak attractive forces between molecules. So that's why you have to choose that option, because their molecules are held together by weak intermolecular forces. Yes, this option is the right option. Whenever they ask you about the melting or the boiling point of the covalent compounds, the reason behind is not a covalent bond. The reason is always the weak intermolecular forces, or you can say the weak attractive forces between molecules. Okay, you always have to choose that option. So that's why option B is the right option. So This option has the right option, that is B. Let's see another question. This is also related intermolecular forces. I'm just giving you 2 or 3 examples so the concept is clear to you. Which statement explain why methane has lower boiling point than water? If you see, methane is CH4. It's also a covalent compound. Water is also a covalent compound because it's made up of non-metal. This one is also made up of non-metals. So it means both are covalent compounds. So why one covalent compound has a lower melting point than other covalent compound? Again, it is the reason. The reason behind is the weak intermolecular forces. So you have to look this one. Methane has weaker covalent bond. Again, wrong. Covalent bonds is not responsible for lower melting or boiling point. Methane has weaker attractive forces. Yes, this option is right. Methane has weaker attractive forces than water. Okay. Water also have weak attractive forces, but methane attractive forces are more weaker than water. That's why the methane boiling point is lower than the water. So that's why this option is the right option. And remember that methane molecules are heavier than water molecules. Melting and boiling point don't depend on any other factor. They just depend on the bonding. Which bond is present will decide the melting and boiling point of any compound. Okay. So the bonding for covalent compounds, which bond is actually responsible for lower melting or boiling point? It's not the covalent bond. It's actually the weak intermolecular forces, or you can say intermolecular force or weak attractive force. Okay, so that's why option B is the right option. Let's see another question. Question 17. Which of the following best explains why graphite, metal, and molten ionic compounds conduct electricity? Okay, to conduct electricity, you need 2 types of charged particles. Either they should be ions or electrons. Okay, only free moving electrons or free moving ions are responsible for conducting electricity or electric current, you can say. So we have to check in which compound either we have ions or electrons. So if you look at the graphite, graphite has free moving electrons. So it has electrons, that's why it can conduct electricity. And it is the only covalent compound that can conduct electricity. All other covalent compounds or elements, they cannot conduct electricity. Graphite is the only covalent, element. Okay, not a compound, it's a only element that can conduct electricity. Metals. Metal can also conduct electricity because they have free moving electrons are responsible to conduct electricity in metals. That's why metals and graphite, both in the solid form, they can conduct electricity. Ionic compounds, they have ions in them. There is no free electrons, they just have ions. So ions are responsible for the electrical conductivity in ionic compounds. That's why ionic compounds are very bad conductor of electricity when they are in solid form. Why? Because in solid form, the ions are not free. It's not only the ions. The free moving ions are actually responsible for to conduct electricity. Okay, so in ionic compounds, we don't have free ions when they are solid. Only in the molten form or in the aqueous form, they have the free ions. That's why ionic compounds are good conductor of electricity when they are in the aqueous solution or when they are melted. Okay, so what is responsible for the electrical conductivity in ionic compounds? Same from the words ions. Okay, so now we have to look at the option that can describe electrons and ions together. All have loosely held protons. Wrong. Protons are positive charged particles. They are not responsible for the electrical conductivity. All have free moving electrons that can transfer energy. Okay, electron is right, but not all of them have free moving, because only metals and graphite have free moving electrons, but not the ionic compound. So we cannot choose this option. Let's see another option. All have mobile. Mobile means free moving charged particles. Yes, that option is right. Because electrons are also particles, ions are also particles. So we can use the word particles for both electrons and ions. So all have mobile charged particles that can carry the current. So that's why option C is the right option. You have to remember free moving electrons are responsible to conduct electricity only in metals and graphite, but not in ionic compounds. In ionic compounds, free ions are actually responsible to conduct electricity. So that's why option C is the right option. Let's see question 18. The diagram represents the general structure of solid Z. If you see, we have positive ions and small electrons. Okay, sometimes the students get confused with the metallic structure and ionic lattice structure, because in ionic compounds, we have positive ions and negative ions, right? And same in the metal. In metals, you will see the positive ions and electrons. So if you look at the option, it is a metallic compound, metallic element, sorry. So metal, can you find any metal here? It's the only one metal that is present, aluminium. So option A is the right option. But sometime in exam, if they give you sodium chloride, so you can be confused. You can think that, okay, it can be sodium chloride because it has positive and negative. So the trick is that the positive and negative ion size will be not so, the difference between the size will be not so large as you can see in this picture. Electrons are very small charged particles. So usually in the exam, if they give you a metallic structure, the negative charge will be too small compared to the positive ions you can see here. But in the metallic lattice, but in the ionic compounds, if you see the structure, the positive ions and negative ions might be same in size, or positive can be bigger and negative can be smaller, or negative can be bigger and the positive can be smaller. Okay, but the difference will not be as much as you can see here. Okay, electron size is too small compared to the metal ion. So it is usually a metallic element. It's not an ionic compound. I hope this point is clear to you. So if you are looking at positive and negative, you should see that electron will be very small compared to the negative ions in the ionic compound. So that's why option A is the right option over here.